talking about how to run Open Toolkit, in the sense, what are the different characteristics of different ways of running it? Because in the end, it's the toolbox that you use to run your conversions, and there's always something around it. Whenever you run a program, there's something that enables you to interact with it. If you're using something like Oxygen, it gives you a graphical view of the program, and you interact with that graphical interface. Same as with Open Toolkit, you interact with it somehow, or someone does the interaction for you. Most people are familiar with the AND approach to communicating with Open Toolkit, requesting it to do things for you. I'm just going to go through a few of the alternatives and then talk about the different characteristics of those. Let's see. No? Where am I? Yeah. Can you see in the bottom of the screen? Not really. Okay. So I decided I don't want to write new slides. Oh, yeah. I don't want to write new slides, so I'll just use the terminal, which is most familiar environment for me. So when you look at Open Toolkit, it's quite low in sort of thinking about the levels of how you interact with various tools. You usually have some sort of graphical layer on top of a program, let's say Oxygen, and then Oxygen interacts with some other instance like the JVM, and then at the bottom there's sort of Open Toolkit, the box, and then internally it does additional communication with various other tools. So it's fairly low, and I think that's one of the challenges that people have. It's quite a toolbox-like thing. It's not an application. And most users are interested in ease of use, that the tool doesn't get in your way, whereas us developers are mostly interested in making it faster, more reliable, fun. Okay. So, yep. So let's do Max. So this is one of the familiar ways of interacting with Open Toolkit. You write a something.properties file where you insert your arguments to the Open Toolkit. Say like args.input, that's a path to a map on my local machine. Then you define the transformation type and then the output directory. Oops. And then when you run it, it's in the bottom of the screen, you can't really see it, but you call AND somehow with the, okay, it's probably updating quite slowly for the people in the webinar, but now it's running AND. And what it's actually doing is, on the command line, you're launching AND bash or shell script, which in turn launches a new JVM instance, a Java virtual machine. And then inside there's a Java program called AND, and a new process object is created, and that then does all the processing for you. So there are a few layers that are in between you and the actual processing. And it took 27 seconds. Java, as some of you know, is a virtual machine that interprets code, and it has this nice feature of a JIT, just-in-time compiler. So while Java is running, it's actually getting faster, because while it's running, it's actually introspecting the code, and it's recompiling some parts of the code that are considered hot, meaning they're used often, to native code, and it becomes faster. So when you run your Java program inside the JVM, initially it's slow. You run it the second time, it gets faster. You run it yet again, it's yet faster. And it's about 10,000 times that a single thing must be called before it becomes too hot to handle and it's jittered. But the things that are compiled or recompiled to native code, those are some things that you'll never see, and the 10,000 limit is actually reached quite fast. So what I just ran is the Open Toolkit documentation. It's a small set of topics. Roger, how many is it? It's not that big, was the answer. So, but if you have, say, 100,000 topics in your document set, then the JVM would have enough time to rerun the same loops and become faster while you're processing that single library. But for smaller libraries, you never reach that. And whenever you run ant, the command script, it always launches a new JVM instance. It never reuses the old one. Thus, it never has enough time to warm up and become faster. So that's what's happening when you run ant. Then there's the DITA command. Okay. Unfortunately, you may not be able to see this in the bottom of the screen. So it's using the new DITA command. And while we marketed the DITA command as something new and cool, it's actually a copy of the ant script, the ant.bat script. It's a copy of it that just does the library management for you. So there's nothing really special about it. So when I run this one, it won't show you any log files right now, but it will take approximately the same time as running ant the batch script, like in the previous example. So it's again using a cold JVM. Then there's Gradle. So DITA-OT plugin for Gradle is something new that Eero, a former colleague of mine from Finland, he developed. So Gradle is a build script, build tool, build automation tool. Similar to Ant, but it's one of the new kids in town. Has features that developers these days want to use. So what the DITA-OT plugin for Gradle does is it runs Open Toolkit, the Ant, inside Gradle. So build automation tool running another build automation tool running custom code. So layers. And it's fairly simple to set up. Eero has very good documentation on it. You basically just create a Gradle file. In the beginning, you say you want to use the DITA-OT Gradle plugin. Then the default task DITA, that's kind of, you have to have that. And then you have to tell it where the DITA-OT is installed on your machine. And then you give it input and transformation type. And then when I run this, just Gradle. What it does, it launches Gradle. Can you, by the way, see this in the audience? Not really, no. So, oh, sorry, I need to do one thing. Stop. Now it's running. Now this is a fresh Gradle. So what it says there, it's starting a new Gradle daemon for this build. Oh. This is demo. Okay, so rf build. So now I want to, oh no, it's, now the daemon's running again. rm or rf build Gradle stop. Now I want to just forget all about that. So I'm running a Gradle script. So it says it's starting a new Gradle daemon. Daemon is a small server that's running on your machine. Normal terminology. And it says subsequent builds will be faster. And what it's doing is it's keeping the JVM alive for you instead of just throwing it away. So when you use Gradle, you're able to reuse the same one and get the benefits of jitting, meaning the warming up phase. So 26 seconds. So that's pretty good. We'll rerun it. And it says 1.1 seconds, which is false, because what it does is it checks whether anything changed in your input files. So it didn't actually do anything now. We can force it to rerun the conversion. So rerun tasks. So now it ignores that the input files are exactly the same and starts to run Open Toolkit. I'm not showing you the results. You just have to believe me that it's actually doing something. So it went from 26 seconds to 9 seconds just by reusing the JVM once. And now it's running Open Toolkit again. And hopefully it'll finish soon. 9 seconds. Wasn't that much faster. Let's see if it gets any faster. 8 seconds, or almost 9. So the improvement isn't hideously much, but it's more than twice as fast for a small-ish set of files. As a developer, all I think about is performance. A technical author might not care whether it takes 26 seconds or 9 seconds, but for me it's a thing that should be considered. And this is the thing that you should take into account if you integrate Open Toolkit with something, that the JVM warm-up phase actually gives you a performance boost. Then there's Oxygen. I'm not going to show you Oxygen because I rarely use it, so I would probably make silly mistakes and Radu would correct me. So it's just a graphical user interface to Open Toolkit that enables you to have drop-down menus for the various properties and so forth. Make it look bigger. So, and it sort of exists for the user, hides the processing that goes or is executed underneath. And Open Toolkit is a tool that can run the JVM out of memory, because if the input set is big enough, the input library, and it's using XSLT without any toggles on, it keeps on reading files in, keeping them in memory, and at some point the JVM will run out of memory, and then instead of becoming slow, it crashes. There's an out of memory error. Error means something went hideously wrong, just crash everything, which is really bad for this type of thing. So that's one of the reasons why Oxygen, when you run Open Toolkit, it creates a new JVM instance and runs Open Toolkit there to protect the environment where the actual editor runs, because you don't want whole Oxygen to crash if your input set is too large. You want the Open Toolkit instance of JVM to crash. So if you're integrating Open Toolkit with something else, there's always the possibility, integrating it with another Java-based tool. There's always the option of splitting it into a new JVM and running it there to protect the parent process. Okay. I don't use CMS, I use Open Toolkit. And you don't need to actually make it visible because no one is interested in that except Robert and I. So we don't know actually how the CMSs integrate Open Toolkit. We can just guess. Some of them might use a bash script that calls start command that calls something that does again something. Or they might have something hideously nice that all of us would want to have in our, I don't know, home. So that's one of the invisible things to an Open Toolkit developer. We have no idea what the CMSs are doing. So this is sort of a call out for CMS vendors. We would actually appreciate if you described your integration story to us. A short 4-paragraph description would be enough. We might actually be able to help you in some cases or make your life easier in the future. Because we don't deliberately want to make someone sad. We bend over backwards to protect the plugin customization developers so that their plugins wouldn't break that much when we release a new version. In a way, it would be the same for the CMS vendors. We don't deliberately want to make your integration story more difficult when you update. It's just that we have no idea what you're doing. Continuous integration. I think Roger had a talk on this a few years ago. So continuous integration, CI systems, they're basically a web server that does jobs for you, simple stuff. In software development, it builds your software and verifies that everything works. It runs your tests. It does the stuff that you could do locally, but in most cases you're happy if someone else does it. Those can be run on your local machine. You can have a Jenkins instance installed locally, but usually it's in the cloud. And the cloud means someone else's computer. It might be a server rack somewhere at Amazon, or then it could be, I don't know, someone else's actual laptop. But oftentimes the CI systems run on someone else's machine, which means if you're using Open Toolkit with a CI system, you can build your stuff on some other machine and you don't actually use your computer's resources. So you can, I don't know, do something more I/O intensive locally while your documentation is building. And CI systems also allow you to have both push and pull approaches to getting the jobs. So you can either tell the CI system, convert this for me, and when you're done, notify me, or I'll come and ask for it, or then they can build them for you. For example, whenever you commit something, it automatically builds everything for you. This is normal procedure if you're a software developer. So because 95% of us are OT hackers, you know software development. I saw that raised hands. So if you integrate your Open Toolkit processing into a CI system, let's say Jenkins, it's actually easy to integrate additional services that are similar to Open Toolkit. What Open Toolkit does, it takes DITA and it does something with it. Okay. Usually it produces a output document that someone consumes with their eyes or ears. It can do quality assurance, like there's a plugin for OT that does it, but it doesn't have to be DITA. So if you start using CIs, you'll be able to integrate additional things that can be automated, and automation is always good. No one wants to do this locally. I don't know what the so-called lone DITA writers do, but even they could use a continuous integration system. Then I wanted to show you something I've been working on or have been thinking about, which is a OT server. This isn't rocket science. Anyone can do this, or you can use any existing tools to come up with something very similar. So Open Toolkit is a single-purpose tool, in a sense. It's not meant to process any XML vocabulary. We can actually add support for DocBook in Open Toolkit. It would actually be fairly trivial to do it, but no point doing that. Absolutely no point doing that. And in a way, you can do and create a DITA processing server using Jenkins or some other CI system, but sometimes it makes sense to create a single-purpose tool for running that. Create an additional layer around Open Toolkit where it's no longer a command line tool, it's no longer a toolkit, it becomes an application, and that application happens to be something that runs in the cloud. And that's what I've been sort of working on or would like to implement at some point. The target audience for a tool like this is probably the enterprise users or tool vendors, CMS vendors, but there's nothing prohibiting the lone DITA writers using this. They could set up a DITA-OT server running somewhere, converting their stuff, but they'd probably be better off using Gradle if they want continuous integration locally, or just use Oxygen, because that's just simple. Unless they're, of course, techies and they actually do want to do that. By the way, if you have questions and not opinions, then just ask. So the intended benefits of the server would probably be that it would be easy to take into use and integrate to other systems, because integration is the key word. You want to integrate your tool to something else, because in the end, that something else is what people use. That's why using Open Toolkit has been so difficult, because there hasn't been a really good integration story, except Oxygen. And if you don't like Oxygen for some reason, then you're sort of stuck with the command line tool. And the idea is that it wouldn't be bound to a single UI. User interface in this means some graphical user interface or the command line tool. So it would need to be some sort of service that can be interacted with. And I view the important bit in this is that it moves the processing away from the users, because you don't want to have Open Toolkit running locally if you can avoid that. Because that way, if you offload the work to a server somewhere, you actually share the CPU and memory. Say you have 10 writers, you can just give them the oldest HP computers you found on eBay, because they only have to edit. They don't have to be able to actually convert anything to PDF. So you share the CPU resources, and in some cases licenses too. You can have 10 individual licenses for all your authors, or just a single server version, and then they all use the same license. Server licenses are always more expensive than a single-use licenses. But at some point you hit the sweet spot and it becomes cheaper to do it on the server. Then there are some platform-independent features, like I can't build the Open Toolkit distribution packages. Robert has to do it because he has a Windows, and we have to build it on Windows because HTML help is only available on Windows. So I can't do that. It's the same way that if, for example, you would want to produce a Word document from DITA, the plugin is there, but with Word you have to actually open it for it to calculate all the page numbers. So you have to open it in Word once and then it's done. And you can automate this by running the conversion on a Windows server and then opening it with a small program, opening it there, calculating all the page references and then saving it, and then you're done. So sometimes the platform your authors are on is a problem. And then it might be easier to update and deploy your plugins. You don't have to distribute them anywhere. You just install them in a single place. You always know what everyone is using. And then there's the idea of hiding the implementation details. You could sell your conversion to someone else, but you never show them the actual plugin. You just sell the conversion as a service. So there are commercial interests here too, or the ideas of possibility for that. I don't know if anyone has a plugin that has some magic in it that you wouldn't be able to share the implementation, but sometimes you do want to hide something. And it's always the mantra that never send a human to do a machine's job, because automation is always good. I'm not talking about having less people to do work, replacing people with shell scripts. I'm just interested in finding more interesting things for people to do while they're working, like not waiting for OT to run. So the proof of concept implementation I have, and I don't have anything like polished and ready. I wrote the UI you are about to see just a few nights ago during nights, so it's really not polished. But it's proof of concept that I'm toying around with based on the white paper I wrote. So it's a REST-based architecture, meaning there's a server somewhere that responds to requests, and then it'll return you something. So it'll just, you send requests to a server, it responds. You send it a job, it says, brilliant, I got that job, here's an ID for the job I created. Call me back in 10 minutes and find out if it's ready. REST-based architecture is what a lot of web services are using, and if you go, for example, to a web shop, you want to buy something online, those are all based on a similar approach that computers talk to each other. It's not a single huge blob. It's not a single computer. We got the implementation stack, or the technology stack. It's based on Scala, which is a Java-like language that runs on the JVM. It uses Akka, which is an actor-based framework for inter-server communication. And then I just added Play framework to allow me to create something that humans can actually consume. The idea is that you allow scalability by having multiple workers. So there's a single hub, a queue, and then you can have multiple workers asking for jobs from that queue and executing those. So you can have one worker on a Windows machine and then 6 on a Linux machine, or various Linux machines, and then you're able to have different types of worker platforms, or one worker might have the license for a PDF renderer, and then the other ones don't. So you're able to organize your environment in a way that not everything needs to duplicate the same setup. And with Akka, you get sort of for free the support for if your worker runs out of memory, it crashes, Akka will just restart it for you. And you can retry that work for example, with different configuration. So you're safe or safer from issues that might come from issues with Java or the way OpenToolkit is implemented. So I have an initial UI, which is really simple, for HTML, but the next one would be Oxygen integration. Initially, very simple. It would look like the normal transformation scenario, but behind the scenes, it wouldn't do anything on your machine. It would just do it on the server. So let's see. This is the initial UI, so a list of jobs. So I want to create a new job. Like I said, this isn't rocket science. You've all seen this before. So it's one file on my machine, the user guide, and then selection of the different transformation types I have, and then a output folder where it would or will write the results. So I could click on create, and then I have to actually hit refresh because it's not doing it myself or itself. So now it's in progress. It's running on my machine. Yeah. So I'm actually proving it's doing something. I was supposed to demo it with a setup where the server was actually in my home, but then the network connection to my home doesn't work anymore, so I can't access it. So I have to demo it locally. But the idea is that you move the processing away from the authors, or it doesn't have to be authors, it has to be something you move it away from. So it took 23 seconds. So if I refresh it here, yep, it did it successfully, and it created it on my local machine. And it doesn't, let's see. Yeah, it's there. So because it's running on my local machine, it can actually write to my hard drive. So this might be a simple way of running it locally. But then if I go back to here. Yep, it's there. So if I create a new one and remove the output and rerun the queuing, rerun it in progress. So if you run this on your network in your company's intranet or some cloud environment, you don't have access to the user's hard drive. So you can't write to it, so something else needs to happen, and we're waiting. The demo effect, it went out of. Okay, let's just crash that. Okay, you get the idea. It would have given you a download link. So you want the processing to occur, but you can't have it right to your own machine, so you just it will save it for you somewhere. And then the next demo bit would have been that you give it a URL that points to, for example, GitHub. It goes to GitHub, fetches the user docs from GitHub, but I can't do it because the network connection is so poor here. And it would again give you a download link somewhere. So nothing new, but the idea would be that you could have a UI like this HTML that runs on your browser to create the jobs. You could have a UI for converting the stuff in Oxygen. You create a transformation scenario. You select, I want to run this on the server. Here's the server URL. It's not my server. It's provided by company X. They do all the processing jobs for me. And then when you run it, at some point, Oxygen will tell you, it's finished. Do you want to download it or share the link? Or then you might have a CMS somewhere wanting to focus on their core business. They don't want to create Open Toolkit integrations, so they'll just install this somewhere, and when someone in the CMS pushes, or CMS UI pushes the button, the CMS software doesn't actually run Open Toolkit. They'll just tell a server somewhere that, okay, someone wanted to convert this, pull it from us, and here's the address we want you to stick the output. So that's just distributing the work out. I probably will not implement this because I don't have time. I started this work, but then I had to stop for 1.3 implementation, and then I started it again, and then I had to stop for 2.2 release. So this is progressing really slowly, but it's a fun project, and I think something that all the CMS vendors might already have. They have a fancy system of running Open Toolkit. But this is the way I would actually want everyone to run it. It's a service you use, not some tool, because this can be made a service. Who offers that service? That's a different question. It can be your own company's IT department. It can be you yourself if the installation story is simple enough. You just type run Open Toolkit server, and then it opens a browser for you, or you know the URL that Oxygen is supposed to use. And it's another layer around Open Toolkit. With regards to performance, this gets the benefits of the server having more CPU and memory than your old HP laptop. So the jobs might be actually faster, even if you transfer something over wire. But you don't necessarily need to transfer anything over wire. If you make edits to your documentation, commit to Git, it'll pull it from Git directly and then deploy somewhere. So the things I'm not interested in is a delivery channel. I don't want this to be something that creates HTML and then hosts it for your end users. That's not what I'm talking about, because that's another service. That service that actually hosts the content for end users, that might use this under the hood. So, because there are way better tools that exist for actually hosting your HTML content or something else. And you might want to properly version your output documents. It would be out of scope for this. And then there's a separate story for access control. You might not want everyone to have access to this. And for example, with this simple POC, the idea I had for access control is that when you create a job, you give it a magic string that no one will be able to guess. Say like 1 gigabyte long string of numbers. No one will be able to guess that by brute forcing. And then you'll be able to get your job back if you give it the magic string again. Hideously simple token-based authentication, but it would work. So some things are in scope, some things are not. I wrote a simple description and few use cases for this. I might be able to share it with some people if they're interested. I hope to be able to do something like this in the future, but we'll see. But now everyone has a clear picture of what it means when you run Open Toolkit, what actually happens, and what is a JVM manager, right? Thanks. Are there any questions? Nope. Okay.
Can I get the slides?
Yeah, I need to. Do you want the error messages?
Yeah, is there, are there any drawbacks memory-wise to running Gradle on a desktop system, like leaving the daemon running?
No, I mean, by default, Gradle daemon will die in 3 hours. So you can basically leave it. And of course, when you're running something locally, you might end up having memory issues, but not that I've experienced. Eero would actually be probably more suited to talk about that. But what Gradle does, it uses Ant as a Java library, so it doesn't launch anything new, it just reuses the same JVM, so it should basically use as much memory as a normal Ant process.
Okay, so it caches in that build directory? Is that why you were...
No, it doesn't cache anything, it just actually looks whether the input files changed.
Ah, okay.
So if I were to change a single character, save it, I could rerun it. And Gradle has a convenient continuous, so it could actually listen to your changes. Whenever you change your documents, it would rerun the conversion. I don't know why you would want that, but it can do it. I mean, maybe QA.
Thanks.
Okay.
Just a little question. Thank you. What is the comment?
Yeah, Jarno. If you have a lot of files to process, can you, let's say, not load balancing, but sending on multiple servers to process it?
Not really, no, because, okay, if you want to get really into it, I suppose what you could do is take the pre-processing that we currently have, then find things that you can do in parallel, and anything you can do in parallel you can do on multiple machines. Open Toolkit and data processing in general, there are these breakpoints when you need to actually have everything available to you and then start again. So you have to process all the files, then in a way stop and then continue. You can't have a single pipe where you start with one topic file, process it to the end, and then start with the new one. Yeah, because there's the map. If you have single topics, not a problem. With map, because map is there, you have keys and branch filtering and so forth, you have to have that. I suppose in theory you could try and do it in one go, but it would probably just have to keep everything in memory and it still wouldn't work.
But I could hand over a zip file with everything in it?
Yeah, I mean...
So just to say, repeat the question. The question was whether a zip file can be used for this.
Okay, so that would be part of the UI, because, okay, it doesn't have to be, but basically yes. It wouldn't need to work the way that you give it a single map and it starts from there. You could just give it a zip file and say that's the map inside the zip that I want you to process. And then actually the map could be the whole universe for that process. So no other files are accessed outside. Because you don't really want to have a situation where someone sends a data processing request to the server, and the map has links to local files on the server, like something.ssh/id RSA. So you don't want to leak information like that. But whenever you go into a server environment, you actually have to think about security issues, because someone will is bound to try and break in, especially if you're building something really awesome. Brilliant, thanks.
Okay, thank you, Jarno.